Imagine this, you build a car for a 5-year road trip, just to Jupiter and Saturn. But instead, it just keeps going, past the edge of our entire solar system and into the vast, unknown space between the stars. That's the incredible story of the Voyager probes. Their mission was only possible because of a rare celestial event that happens once every 175 years. Jupiter, Saturn, Uranus, and Neptune all lined up on the same side of the Sun. This allowed the Voyagers to use each planet's gravity as a slingshot to hop to the next. NASA called it the Grand Tour. The launch itself was a bit of a race. Voyager 2 lifted off first in August 1977. But 16 days later, Voyager 1 launched on a much faster path and quickly overtook its twin. Just 13 days into its journey, Voyager 1 turned its camera back towards home and took a picture that would become legendary, the very first family portrait of Earth and the Moon seen together from space. Our home, just a tiny blue marble hanging in the infinite black. A year and a half later, in early 1979, Voyager 1 arrived at the king of our solar system, Jupiter. It was our first ever up-close look at this colossal world, with its raging storms, intense radiation, and a collection of moons so vast it's like a mini solar system of its own. When the images from Voyager 1 and 2 started coming back, they completely rewrote the science books. The probes discovered Jupiter's faint, wispy rings, which we never knew existed. They found 3 new moons, Thebe, Métis, and Adrastea. They gave us breathtaking close-ups of Jupiter's giant moons, turning distant specks from our telescopes into real, detailed worlds. And of course, there was the Great Red Spot. For centuries we'd wondered about this giant storm, larger than Earth itself. Voyager confirmed it was a massive hurricane, spinning counterclockwise like a cosmic monster. But the biggest shock came from Io, one of Jupiter's moons. The probes captured images of active volcanoes erupting on its surface, the first time we'd ever seen active volcanism anywhere besides Earth. Io is so dynamic, it's still known as the most geologically active place in our solar system. Then there was Europa. Its surface was a smooth, glassy shell of ice, crisscrossed with cracks. The images sparked a revolutionary idea: what if there's a giant ocean hidden beneath that ice? A world of water, protected from space, on a moon orbiting Jupiter. It instantly became one of the most promising places to search for extraterrestrial life. After their groundbreaking visit to Jupiter, the Voyagers used its immense gravity to slingshot themselves toward Saturn, arriving in 1980 and 1981. For the first time, we saw Saturn's rings not as a single band, but as a stunningly complex system of thousands of individual, narrow ringlets. The probes also found 4 new moons. One of them, Mimas, with its enormous Herschel crater, looked uncannily like the Death Star from Star Wars. Here, the mission team faced a critical choice. They wanted a close look at Titan, the only moon in our solar system with a thick atmosphere. What was hiding beneath its dense, orange haze? The problem was, Titan's atmosphere is completely opaque. Voyager couldn't see the surface, but it analyzed the air and made a huge discovery. It's just so cold on Titan that methane acts just like water does on Earth. It can exist as a solid, liquid, and gas. This discovery paved the way for later missions to find actual lakes and rivers of liquid methane on Titan's surface. But this close look at Titan came at a cost. To get there, Voyager 1 had to be thrown off the main path of the planets. It could never visit Uranus or Neptune. This was the moment that separated the destinies of the 2 probes. While Voyager 2 continued its grand tour, Saturn's gravity flung Voyager 1 into the history books, making it the fastest spacecraft ever. Its new mission? A one-way ticket out of the solar system, into the great unknown. Meanwhile, Voyager 2 pressed on. In January 1986, it arrived at Uranus. This was a totally different kind of planet. Beneath its atmosphere wasn't just gas, but a slushy mantle of water, ammonia, and methane ice. This is why we now call planets like it ice giants. Voyager 2 found that Uranus's magnetic field was bizarrely tilted, almost on its side. Its atmosphere was eerily calm, like a smooth, pastel-colored orb. 3.5 years later, in August 1989, Voyager 2 reached its final destination, Neptune. It became the first, and so far, the only spacecraft to ever visit our solar system's most distant planet. From far away, Neptune looked serene, but Voyager 2 revealed a world of chaos. It clocked winds screaming at over 1,000 kilometers per hour. And it spotted a massive storm, similar to Jupiter's, which was named the Great Dark Spot. The biggest surprise at Neptune came from its moon, Triton. Voyager 2 saw active geysers erupting from its surface, spewing nitrogen ice into space. It was another geologically active world, boiling with mysterious energy in the freezing depths of the outer solar system. With that, the grand tour was complete. While Voyager 2 was exploring the ice giants, Voyager 1 was already on a lonely path out of the solar system. Most of its instruments were turned off to save power, but it had one last gift for us. On Valentine's Day, 1990, from 6 billion kilometers away, it turned its camera around one final time. It took a photo of our home, a tiny speck of light just 0.12 pixels in size. That image, the pale blue dot, was the last picture Voyager 1 ever took. Its cameras were shut down forever. But that image, and the profound words it inspired from Carl Sagan, reminded us that everything we've ever known, all our wars, our joys, our entire history, is contained in that single, tiny point of light. After this, the Voyagers went quiet for a long, long time, just two old travelers drifting through space. Then, on August 25, 2012, something changed. Voyager 1 detected a sudden drop in solar particles and a sharp rise in cosmic rays from deep space. It had happened. It had crossed the heliopause, the invisible boundary where the sun's influence ends. Voyager 1 had become the first human-made object to enter interstellar space. Voyager 2 followed it across that same border in 2018. The data they sent back from this cosmic frontier was astounding. The sun's solar wind doesn't just fade away, it stops dead, like hitting a wall. And the pressure from outside our solar system is 10 times stronger than we thought. Voyager 1 even detected a faint, constant hum out there in the interstellar void, a 3 kHz tone, like the background noise of the universe itself. We also learned that our sun is sitting inside a giant, 1,000 light-year-wide void called the local bubble, cleared out by ancient supernova explosions. We're living in a cosmic protective bubble and didn't even know it. And they're doing all of this with shockingly old technology. Their computers have a total memory of about 70 kilobytes. A single notification sound on your phone takes up more space. They record their data on 8-track tape recorders. And they send it all back to us using a transmitter with the power of a refrigerator light bulb. Their lifeblood is 3 generators that convert heat from decaying plutonium into electricity. But after nearly 50 years, these old travelers are starting to show their age. In November 2023, Voyager 1 went silent, sending back nothing but gibberish. The problem was a failed memory chip. Getting a message to the probe takes 22.5 hours, and a reply takes another 22.5. But after months of painstaking work, beaming commands across billions of kilometers, the NASA team pulled off a miracle. On April 20, 2024, Voyager 1 started talking again. It was like hearing a heartbeat return. Even though they've crossed into interstellar space, they haven't technically left the solar system. That boundary is the Oort cloud, a vast sphere of comets so far away it will take Voyager 1 another 300 years just to reach its inner edge, and 30,000 years to cross it completely. Long after they fall silent, their journey will continue. And on that journey, they carry a message from all of us, the Golden Record. It's filled with pictures of Earth, greetings in 55 languages, the sounds of wind and rain, a baby's cry, and our music. It's a message in a bottle, cast into the cosmic ocean. Maybe no one will ever find it. But what matters is that we sent it. The Voyagers are more than just machines. They are a symbol of our curiosity, our courage, and our unending desire to reach for the stars. And as they travel onward, into the silent darkness, a piece of humanity travels with them. They are no longer just NASA's probes. They belong to all of us.